Okay, Budit. Good morning. Today we are going to discuss about the insertion of vector. We have discussed up to uh, taking resulting vector of a vector system. So in that case, as the first method, we have used resolve it method. We have done several applications, several questions based on that. Okay. अभी रिसॉल्व करा दो. We have done up to resolving a vector and resolving vector. Or have we done about taking resultant force using resolving method? Taking resultant force using resolving method. Taking resultant force using resolving method. Have we done that thing? Resolving method, don't you know? Okay. That means we have done taking resultant force of vector system using resolving force, no? Using resolving method, no? Is it okay? Thank you, thank you. Okay, so in that case, resolving method means actually the resolving means we can reduce a vector system into two perpendicular vectors. We can reduce a vector system into two perpendicular vectors using resolving method. Right? Therefore, actually, according to our previous knowledge about taking resultant force, actually we know how to take resultant force of two vectors. We know that thing. And how to know resultant force of two vectors using vector parallelogram method. Actually, we know that thing. But if we are given more than two vectors, that means if we are given a system of vectors, sometimes there may be 5 vectors, 6 vectors, maybe 7 vectors, any number of vectors. If we are given such kind of vector system, actually we cannot directly take the resultant force with it because there are a lot of vectors. So in such cases, we can reduce that number into 2 using resolving method. Using resolving method, we can take 2 perpendicular resolve component of the vector system. Then we can apply vector parallelogram method. Vector parallelogram method. Actually, this vector system is resolved or reduced into 2 perpendicular vector. We can equate this vector system into 2 perpendicular vectors. Suppose this one F1, F2, F3, F4, F5, F6. So this is the summary of that lesson. A vector system can be reduced into 2 perpendicular vector by resolving. Now you can reduce that vector system into one single vector by taking the resultant vector of these two vectors. That means It is the resultant vector. It is a resultant vector. If you can represent a vector system by one single vector, which can give all the properties of the vector system, that vector is called the resultant vector. Okay. Therefore, taking resultant vector means reducing the vector system into one single vector, or equating the vector system into one single vector. And that vector can give all the properties, all the characteristics of that vector system. Therefore, you can replace that vector system by that single vector. That is the reason we call it as the resultant vector. Okay. Then we can take the resultant vector. The resultant vector is equal the square root of v square plus qv square. So this is the resultant force. Therefore, if you are given a vector system, you can reduce that vector system into two perpendicular vector by resolving. Then you can take the resultant vector. So this is the summary. You can note down that summary. Okay. Now we can discuss the second method. The second method. Second method. Taking the resultant vector, taking the resultant vector, taking the resultant vector when the vector system is represented, when the vector system is represented in when the vector system is represented geometrically. Taking the resultant vector when the vector system is represented geometrically. Yeah. Within the brackets, right? Vector, principle of vector addition, principle of vector addition, principle of vector addition. Suppose you are given a vector system in geometrical way. That means those vectors are represented in geometrical figure. Geometrical figure means by magnitude as well as direction. Okay, because sometimes vector can be represented using a geometrical figure, but the geometrical figure is not drawn to a scale. So in such cases, we cannot use this method. Actually, this method can be used only when the vector is represented geometrically. Geometrically means using a line segment. Using a line segment, and that line segment should be drawn to a scale as well as it should be represent the direction of the vector. So in such cases, we can use this method. Okay. Suppose now vectors are represented geometrically. If they are represented geometrically, this line segment can be represented that vector. So in such cases, Pute, we can go to our basic principle. So what is our basic principle? Basic principle is principle of vector addition. So all the derivations are based on that basic principle actually. Yeah. Not only other principle, Pute, but also vector polygon law is based on that vector parallelogram law, also based on that principle. Therefore, that is our base. Therefore, if you are given more than two vectors, C, D, can be. If you are given more than two vectors to be added, then we can use the principle of vector addition. But actually, how to take a resultant force. If you want to take the resultant force, you have to take the vector addition of that vector system. You have to take the vector addition of that vector system. Therefore, if you are given this kind of vector system, these kind of vectors which are represented geometrically, you can take their vector addition. You can take their vector addition in order to take the resultant vector. Therefore, just take the vector addition. I've done that thing. If we are given a system of vectors, which are represented geometrically, We can get the vector addition. We can get the vector addition in order to determine the result vector. In order to determine the result vector. Yeah. Okay, but now you are given this kind of vector system. This kind of vector system. So how to take the result first? You have to add them. You have to take the vector addition of them. You have to take the vector addition of them. So how to take the vector addition? It is very simple. You have to first you have to overlap the term, the endpoint of the first vector and the starting point of the second vector. You have to overlap the endpoint of the first vector and the starting point of the second vector. Endpoint of the first vector and the starting point of the second vector. You have to overlap them. You have to overlap them. So once you overlap, you can have this kind of figure. A, B to K, and B and C are overlap. This is A. Then this one B. Then D and E are overlap. This is F. F and G are overlap. Here H. Okay. So when you are taking the vector addition, using principle of vector addition, you have to overlap the end point of the first vector and the starting point of the second vector. End point of the first vector and the starting point of the second vector. End point of the first vector and the starting point of the second vector. Once you overlap them, then you will have two free ends. You will have two free ends. One is the starting point. This is the starting point. And this is the end point. So if you construct a vector, from this starting point to end point, if you construct a vector from this starting point to end point, you will have the addition of those vectors. You have the addition vector, therefore this vector represents the addition. That means A plus B plus C plus D. Okay, therefore this should be the resultant vector. This should be the resultant vector. If you get that thing, please raise the hand. There are person. Make it. Another. Okay. Okay. Look at this one. Now, when you add in a vector system using vector addition principle, the first thing, those vectors should be represented geometrically. That means by a line segment, which is drawn into the which is drawn into the direction of vector, and the length should be corresponding to the magnitude of the vector. Therefore, both magnitude and direction should be represented. And okay, Puti. So if so, you can take the vector addition like this. Now we are going to discuss some special cases. Look at this one. Look at this one. So when you are getting the addition, you have to overlap each and every starting point and end point. You have to overlap each and every end point and starting point. Once you overlap end point and starting point, then there will be a gap between the initial starting point and the final end point. There's a gap, no? If there is a gap, now it is very clear there is a magnitude for the resultant force. There's a magnitude for the resultant force because now resultant force is equal AH vector. AH vector. The resultant force is equal to the AH vector. Therefore, R is equal AH vector. Yeah. Somehow, if when you are overlapping each and every endpoint and starting point, if H and A also overlap, if H and A also overlap, then what will happen? Actually, now here Pute, GH vector is into this direction. No? So if GH vector is into this direction, and which is equal FA, then what will happen? Now this vector is into this direction. Therefore, definitely you will have a gap. Then you will have a gap. If somehow if you have this kind of vector system, I did. I had all of this student. So whether the itself the resultant force is equal H vector, resultant force is equal H vector. R is equal H vector. Maka nakadikit. Now, FLC, sorry. Putting on method FLC, sorry, ENG, this should be ENG. ENG. Method C name ENG. There should be ENG. First, B and C is overlap. B and C are overlap. Then D and E are method D and E. Sorry. D and E. D and E are overlap. Then E and G are overlap. Sorry. Whatever. Confused. B and C are overlap. D and E are overlap. Then E and G are overlap. Okay. අදාගෙන කලින් figure එක ඔයගොල්ලෝ එහෙම දැම්මම. Now we have to write, we have to draw GH vector. Suppose this GH vector is equal to this length and this direction. So if GH vector is equal to this length and direction also equal to EA, then what will happen? Then definitely the point H should be at the same point with point A. Definitely point H and point A should be overlap. They should be overlap. A and H should be overlap. If A and H overlap, if A and H are 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 overlap, what will happen to the if A and H are overlap? What can you say about AH length? If A and H are overlap, what can you say about AH length? Definitely, now there is no H line segment. There is no H line segment. Therefore, AH length should be 0. It should be 0. Now there is no H line segment because A and H are overlap. That means in such cases, if H line segment is 0, definitely you know H line segment is equal to resultant force to put it. H line segment is equal to the resultant force. Therefore, the length of H line segment should be equal to the magnitude of the resultant force. Therefore, the length of H line segment should be equal to the magnitude of the resultant force. That means, if so, the resultant force should be 0 because now there is no H line segment. Because now there is no H line segment, the length of H line segment is 0 today. That means the resultant force should be 0 today. The resultant force should be 0. Look at this one. So if you are adding a vector system using vector addition principle, and if you get a closed loop, now this loop is closed, no? Now this loop is closed. If you get a closed loop, that means now there's no gap between the initial starting point and the final end point. If there's no gap between the initial starting point and the final end point, definitely the resultant force should be zero. The resultant force should be zero. That means when you are applying vector addition principle into a question, and if you get a closed loop, that means the resultant force of that force system should be zero. Is that clear? Teyana Tusa. Dilana Tusa. There are topic. There are topic. Occasions where the resultant vector is zero. Occasions where the resultant vector is zero. Okay. Where Have a good day. I finish. They write this one. මේක ලියලා කොටු කරන්න බලන්න ලියලා ගන්න. That means after applying the principle of vector addition, after applying the principle of vector addition, if the initial starting point and the final end point, if the initial starting point and the final end point if the initial starting point and the final end point if the initial starting point and the final end point are overlapped, the resultant vector of the vector system will be 0. The resultant vector of the vector system will be 0. Will be 0. මේකත් වෙනම ලියලා කොටු කරගන්න. So if there's a closed loop, if there's a closed loop, if there's a closed loop, the resultant vector of that closed loop vector system, resultant vector of that closed loop. If there's a closed loop, the resultant vector of that closed loop should be 0. Should be 0. Now we can look into the questions based on this theory. Now we may discuss what kind of questions can be in our paper based on this theory. Okay. The write a topic. Application of the theory. Application of the above theory. Application of the above theory into questions. Into questions. Application of above theory. Application of the above theory into questions. Balam. Pute, actually, when it comes to questions, we are not given this kind of vectors. That means we are not going this kind of vectors to be added. Pute. Normally, we are given a vector system using a geometrical figure. Using a geometrical figure, something like this. Now, suppose this is a geometrical figure. A, B, C, D. Now, there are vectors like this. Now, there are vectors like this. Here AB vector, there BC vector, CA vector, AD vector, and DC vector. Suppose these vectors are represented geometrically. That means, suppose these vectors are represented in magnitude and direction using this geometrical figure. If you are given such kind of statement, if you are given such kind of statement, that means these vectors are represented geometrically. These vectors are geometrically using those line segments. Using those line segments. Now, you are asked to determine the resultant vector of this vector system. You are asked to determine the resultant vector of this vector system. So if you are given this kind of question, that means you have to apply vector addition principle. We have to apply vector addition principle because all the vectors are represented in magnitude and direction. In magnitude and direction using a geometrical figure. That means they are represented geometrically. That means you can apply vector addition principle because actually you have to apply vector addition principle, otherwise no option. Otherwise no option because we are not given any magnitude of vectors. We are given just a line segment. Therefore, you have to apply vector addition principle. So when we apply vector addition principle, we can follow these steps with it. And actually, vector addition principle means we have to overlap endpoint and starting point. We have to overlap endpoint and starting point. If you overlap endpoint and starting point, so here A, B, and DC vector. Here the endpoint of D, AD vector. D means endpoint of the AD vector, and and the starting point of the CD vector. That means these two vectors are overlapping. These two vectors are overlapping. So actually, if you are given this kind of question, sometimes automatically endpoints and starting points can be overlapped. Can be overlapped. Automatically, starting point and endpoints of vectors can be overlapped. Therefore, you just need to take the resulting vectors only. This is very easy. This is very easy because most of the cases, those vectors, the endpoint and starting point of those vectors are overlapped. Therefore, you have to take the addition of them separately. But now it is very clear. This is the endpoint of AD vector and starting point of DC vector. Endpoint of AD vector and the starting point of DC vector. That means they are overlapped. That means they are overlapped. Therefore, you can add them. Once you add them, you can take the addition of them. And likewise, you can add all the vectors. But here there are some special methods or steps to take the result vector. The first thing you have to consider whether there is a closed loop or not. Sometimes there may be more than one closed loop. So this is a very simple diagram. Sometimes you may be given some complicated diagrams. So in such cases, there may be more than one closed loops. But the first thing you have to consider whether there is a closed loop or not. Closed loop or not. If there's a closed loop, then you can remove that closed loop because you know the resultant vector of that closed loop is 0. Therefore, you can remove. Then බලමු step 3. And if you are given this kind of vector system, this kind of figure, and asked to take the resultant vector, so ultimately you have to reduce the vector system into one single vector. You have to reduce that vector system into one single vector. That is your ultimate objective. Therefore, now there are 1, 2, 3, 4, 5 vectors. Now 1, 2, 3, 4, 5 vectors. You have to reduce that vector system one by one into one single vector. If you can reduce the vector system into one single vector, that one single vector should be the resultant vector of the vector system. Okay. My argument is clear. If you get my argument, please raise the hand. You have to reduce the vector system into one single vector. All right. Now, my objective is reducing vector system by into one single vector. So in such cases, I can do like this. Actually, if there are two vectors like this, now it is very clear the endpoint of the first vector, the endpoint of the first vector and the starting point of the second vector are all. Therefore, if I draw a vector from this point to this point, it should be the resultant vector of them. It should be the resultant vector of them. It should be the resultant vector of them. Therefore, if you are given two vectors like this, you can reduce that two vectors into one single vector by taking the resultant. Therefore, instead of these two, I can draw this one. I can do this one. Therefore, in similarly, we can reduce the number of vectors. We can reduce the number of vectors. Is that clear? ඒක තේරුණාද? පැහැදිලිද? මෙහෙම අපි number of vectors ගැන reduce කරගෙන යන්න. හරි. බලන්න අපි වැඩි කරන්න හැටි. වැඩි කරන්න හැටි කොහොමද? Suppose now you are given this kind of vector system. You are given like this kind of vector system. Now it is very clear if you consider about AB, BC, and CD, CA, it is a closed loop. If you consider these three vectors, if you consider these three vectors, this is a closed loop. Is that clear? If we consider these three vectors, it is a closed loop. Is that clear? පැහැදිලිද? ඒක closed loop එක. තේරුණාද? මේක closed loop එක. So, if you consider the resultant vector of AB vector, BC vector, and C vector, therefore, if we consider the resultant vector of AB plus BC plus CA, definitely the resultant force or resultant vector should be 0. It should be 0. Therefore, resultant of these vectors, three vectors, therefore the resultant of these three vectors should be 0. It should be 0. Therefore, the resultant of these three vectors should be 0. Now, I can draw this again. Here, AB vector, BC, AB vector, BC vector, CA vector, AB vector, BC. Now, it is very clear if you consider about these three vectors, if you consider about these three vectors, this is a closed loop. 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 As this is a closed loop, definitely the addition of these three vectors, the resultant of these three vectors, the resultant of these three vectors should be 0. Addition of these three vectors should be 0. Is that clear? If you get that from, please say that. තේරුණා තුස්සන්? පැහැදිලිද? Actually, the resultant force of vector system, the resultant force of this vector system should be equal to addition of AB vector plus BC vector plus CA vector plus AD vector plus BC vector. Is that clear? This is the resultant force of this vector system. Now, if you consider about these three vectors, the addition is 0. The addition is 0. Or never gonna pull B to B overlap, then A to C, then C to C overlap cancel. A to N. And the return A to A. A to A. That means the result is 0. The result is 0. Therefore, Therefore, we can remove that 3 vector. If there's a closed loop, we can remove. We can remove. That means these two are the only remaining vectors. These two are the only remaining vectors. Therefore, the vector system is reduced to 2 vectors. The vector system is reduced to 2 vectors now. AD, BC. AD and BC. Actually, now we can apply vector triangle. Vector triangle or vector triangle means vector addition with it. Now I can add vector addition principle to reduce this vector into one single vector. Okay. Now this is the starting point of, so this is the starting point. This is the starting point of the first vector, and this is the end point of the first vector, and the starting point of the second vector. And this is the end point of the second vector. Therefore, how to take the resultant vector? You just need to construct a vector from A to C. A to C. So you have to construct a vector from A to C. This is the resultant vector. Therefore, once you take this one as 0, then R is equal AD plus BC. Now these two are overlap with A, these two are overlap. Then what will happen? The R or resultant vector should be equal to A to C vector, A to C vector. Is that clear? පැහැදිලි නම් අතුස්සන්න ගත්තේ. තේරුණා අතුස්සන්න ගත්තේ. පැහැදිලි. And first you have to consider whether there is a closed loop or not. If there's a closed loop, yes, you can remove it. Once you remove closed loop, then you can take the addition. And how to take addition? You have to consider vectors whose endpoint and starting points are overlap. If you consider about these two vectors, they are the endpoint of the first vector and the starting point of the second vector are overlap. And how to consider what? Right? If they are moving into same direction, definitely the endpoint of first vector and the starting point of the second vector should be overlap. Then instead of these two, I can take the resultant vector of the. If you got that, please raise the hand. Okay, then draw this one. Okay, sorry, topic Okay, then. Hello. They write this one. Have finished, Roman? Have finished? Okay, then write this one. Suppose the above vector system is represented. Suppose the above vector system is represented Suppose the above vector system is represented in magnitude and direction, in magnitude and direction, in magnitude and direction, using the above figure, using the above figure. So we can apply principle of vector addition. So we can apply principle of vector addition to take the resultant force, to take the resultant force, to take the resultant vector, to take the resultant vector of the vector system, to take the resultant vector of the vector system. Write it another para. This is the argument. The resultant vector means the single vector, the single vector that can replace the vector system, that can replace the vector system. That means we have to reduce the vector system into one single vector. That means we have to reduce the vector system into one single vector. Look at my argument. Look at my argument. That means we have to reduce the vector system into one single vector. Write down the T. That means we have to reduce the vector system into one single vector. Look at this one, Buddha. Everyone, please look at the book. Now, what is my objective? What is my objective? To reduce the vector system into one single vector. To reduce the vector system into one single vector. Therefore, Buddha, you have to consider some set of vectors. You have to consider some set of vectors. Either this one or this one, or you can consider some set of vectors. Some set of vectors. And so, if you consider some set of vectors, and you can take the resultant force of that resultant vector of that set of vectors. Suppose I have considered this set. I have considered this set. I have considered this set. So, if you consider this set, it is very clear this is a closed loop. The starting point of the vector system is A. The starting point of the vector system is A, and the endpoint also A. That means the resultant vector should be 0. Likewise, Pute, you have to consider a set of vectors. You have to consider a set of vectors which can be added. How to determine whether they can be added or not? How to determine? It is very clear. The endpoint of the first vector should be the starting point of the next vector. The endpoint of the one vector should be the starting point of the next vector. The endpoint of the one vector should be the starting point of the next vector. That means we can add it. And simply we can understand whether they can add or not. If they are into the same direction, they are into the anti-clockwise direction, they are into the same direction. If you move your finger, if you can move without any obstruction, then they are in the same way. Okay. Now, it is very clear. If we consider about A to B, and B to C, and C to A, I can add them. If we add them, the resultant force is 0, resultant vector is 0, then that means we can remove all of them. Okay? Because addition is 0. And likewise, Pute, you have to consider some set of vectors. And take the resultant force, take the resultant vector. So once you take the resultant vector, you can remove that set of vector and consider that single vector. Okay. Now you have reduced some amount of vectors, Pute. So now that set of vector can be replaced by that single vector. Then the vector system is reduced to some another vector. Again, you can consider some set of vectors. Again, apply the same procedure. So continue that operation until you reduce the vector system into one single vector. Is that clear? If you clear that thing, please raise them. For convenient purpose, we can first consider whether there's a closed loop or not. Now it is very clear this is a closed loop. Therefore, we can remove it. Instead of taking resultant force 2 by 2, of 2 by 2, first we can consider as closed loop. So once you take a closed loop, once you can find a closed loop, definitely you can remove all of them. And closed loop Marlon I've done the P. Write in another para. In order to do that, in order to do that, in order to do that, we should consider a set of vector. We should consider a set of vector. We should consider a set of vectors which can be added. Which can be added. So they can be replaced by their resultant. They can be replaced by their resultant. Then consider another set of vectors which can be added. Consider another set of vectors which can be added. We can continue this process. We can continue this process. We can continue this process until we get a single vector. Until we get a single vector. Write another para. For convenient purpose, the following methods can be applied. The following methods can be applied. Following steps to that. Following steps can be applied. For convenient purpose, the following steps can be applied. And the first step. Number one. Determine whether there's a closed loop or not. Whether there is a closed loop or not. If there's a closed loop, remove all the vectors in that closed loop as their resultant is 0. Remove all the vectors in that closed loop as their resultant is 0. Once all the closed loops are removed, once all the closed loops are removed, consider a set of vectors which can be a and take the result. Take the result. Do the same procedure until the vector system do the same procedure until the vector system is reduced to one single vector. So this is the method for it. This is the method. Yeah. Now take your tip. Take your tip. Now this page numbers finding the resultant of vector system. Finding the resultant of vector system. Turn into this page. Finding the resultant of a vector system. Page numbers very large. Yes. Turn into other page, the next page. Now, do the question number 4. Do the question number 4. You have to determine the resultant vector of those vector systems. Now there are 1, 2, 3, 4, 5, 6. There are 6 vector systems. There are 6 vector systems in question number 4. Please determine the resultant vector of those vector systems. And tak keren. Okay. Shall I look into the questions? Shall I look into the question? Have finished? If you finish, please raise the hand. Oh, very good. Okay. Now we can look into the first question. The first thing you have to know now, all of these vectors are represented in magnitude and direction by this geometrical figure. You have to assume that thing. Okay. Alright. Now, suppose we are going to solve the question number 1. So first thing you have to understand, first you have to determine whether there are closed loops or not. Is there a closed loop? Are there any closed loop? Closed loops තියෙනවා තුස? දැක්කද? Yes. If there's a closed loop, please mention it. ටක් ගන්නට answer දෙන්න. So what is the closed loop? What is the closed loop? Or what are the closed loop in this figure? What are the closed loop? මොනවද ඔයා දැක්ක closed loops ටික? ටක් ගාලා කියන්න. රෂිත සරන්නේ? Atafa? ABC, yes, ABC is a closed loop. ABC is a closed loop. ABC is a closed loop. If you think differently, please let me know. If you saw any other closed loop, please let me know. මෙතන D නේ. sorry මෙතන D. මොකද්ද ADC closed loop no? It is not a closed loop. ADC is not a closed loop නෙමෙයි. මෙහෙම ගියාට මේ පතර යන්න බෑනේ. Closed loop means all the vectors should be into the same direction. All the vectors should be into the same direction. මෙහෙම ගියා මෙයා ඉන්නේ අනිත් පැත්තේ. This vector is into other side. Therefore, it is not a closed loop. Yes, very good. Very good. That is the most important closed loop. That is the most important closed loop. How does Yoshi tell you? This is not a closed loop. This is not ADC. ADC is not a closed loop. ADC is not a closed loop because these two vectors are into same direction, but this vector is into other direction. Is that clear? But the largest closed loop is A, B, C, D පුතේ මෙන්න මේක. That is the largest closed loop. All the vectors are into the same direction. Same direction means same anti-clockwise, same rotation direction. But all are into the මෙතනින් පටන් ගන්න මේ A වලින් පටන් ගන්න A B B C C D D A start from A and finish at A. Therefore, we can remove all of them. Because their resultant is zero. So once you remove all of them, what will happen? There's only one force. That is CA. Therefore, that should be a resultant. Because resultant means you have to reduce the vector system into one single force. So if you remove all of them, this is your one single force. So answer is very easy. CA. This is the answer. If you got my explanation, please raise the hand. දැන් මේක බලන්න. මේකනේ අපි කරපු question එකම නා. මේක අපි කරපු question එකනේ. No need to discuss it again. Therefore, answer is AC නේ. Answer is AC. Answer is AC. No need to discuss it again. This is our example question. Answer is AC. Third one, what is the answer? Third one, is there any closed loop? In third one, is there any closed loop? No, there's no closed loop. Actually, the geometrical figure is also not closed loop. Therefore, there's not a closed loop. But it is very clear. AB vector, BC vector, CD vector, and DE vector. All the endpoints and starting points are overlap. Therefore, what is the resultant vector of them? What is the resultant? What is the resultant vector of third one? Tagalog. I need answers from everyone. Okay, very good. Puthe. Saral, Yosita. What is the resultant vector? Resultant vector. Yes, very good. Puthe. Yes. Now it is very clear. Now it is very clear. This vector, this is the endpoint of this vector, and this is the starting point of the second vector. They are overlap. Now it actually all vectors are in the same direction, same rotation direction, same rotating direction. Then the starting point and end point should be overlap. All are into the same rotating direction. All are into the clockwise rotation. This is a clockwise rotation. So is endpoint of the first vector, and starting point of the second vector are overlap. Here, endpoint of the second vector and the starting point of the third vector are overlap. Here, the starting point of the last vector and the endpoint of the third vector are overlap. Therefore, all are into the same direction. Therefore, how to get the resultant vector? You have to construct a vector. From the starting point to end point. The starting point of the first vector to the end point of the last vector. The starting point of the first vector to the end point of the last vector. So this should be the result. Here, the result should be AE vector. You have to change that one as E puthe. Sorry, it should be E, and this point has to be D. Okay, you have to change like this. You have to change. Then this one. Fourth one. What is the answer for fourth one? Fourth one. What is the answer? Two times DC. Well, is there a closed loop? Is there a closed loop? No. There's no closed loop. If there's no closed loop, take the addition of vectors as much as possible. So in such cases, you have to consider a vector system. You have to consider a vector system as long as possible. ඒ කියන්නේ ඇඩ් කරන්න පුළුවන් විදිහට තියෙන වෙක්ටර් සිස්ටම් එකක් බලන්න පුළුවන් තරම් තියෙනවා. වෙක්ටර්ස් දෙකකින් විතරක් නවතින එකක් බලලා තේරුම්න්නේ. Okay? So if you consider about these four vectors, make, all of them are into same rotation direction. මේ පැත්තට යන්නේ ඔක්කොම යන්නේ මේ පැත්තට. මෙහෙම. Now it is very clear the end point of the first vector, end point of the first vector and the starting point of the second vector are all. End point of the second vector and the starting point of the third vector are all. End point of the third vector and the starting point of the fourth vector are all. You can clearly identify it using the same rotation direction. If they are in same rotation direction, definitely they should be starting point and end point should be over. එහෙනම් මේකේ එකතු කරන්නේ 1 2 3 4ක් තියෙනවා. So what is the addition? DA, EA, AB and BC. So you can remove all of them. And if you take the resultant vector, of these four forces, definitely this is the starting point, this is the end point. You have to draw a vector from D to C. If you draw a vector from D to C, you can remove all of them. Now there are two vectors. Now we have removed all of them. Now there are two vectors into DC direction. Now there are two vectors into DC direction. No? Initial DC, and now there are another vector into DC direction. Therefore, the resultant should be 2 times DC. The resultant should be 2 times DC put here. Because now there are two vectors into the same direction. With same magnitude. Therefore, DC plus DC is 2DC. Did you get my explanation there now, Tussan? Okay. Then the fifth part. What is the biggest closed loop? What is the biggest closed loop in fifth part? Tag again. I need answers from everyone. What is the biggest closed loop in the fifth question? Yes, that's a fine, correct. Sarah Nevanta? Yes, Rashita, you are correct. Look at this over there. A, B, B, C, C, D, D, E, E, F. Sorry, E, A. ඒ වලින් පටන් ගත්තා මෙහෙම ගියා ඒ වලටම you can start from A and in at A. Therefore, that is the biggest closed loop in this question. So the resultant vector of those vectors should be 0. The resultant vector of those vectors should be 0. Therefore, you can remove all these vectors. You can remove all these vectors. If you remove all of them, now there are only two forces. Now there are only two vectors, C to E and E to B. A, B. Now, there are only two vectors to be added. Put a C to E and E to B. CE plus EB means you can apply vector triangle. Therefore, we design to same direction. Therefore, this is the starting point. This is the end point. We have to draw a vector from the starting point to end point. This is the starting point and this is the end point. You have to construct a vector from the starting point to end point. Therefore, answer is CB vector. The result is equal CB vector. If you got that one, please raise the hand. තේරෙනවද උස්සන්න? On the final one. Okay. Sorry, call up. So what is the tell me what about closed loops today? It's a closed loop to you. There are several closed loops. මේකන closed loop ගොඩක් තියෙනවා. Closed loops ගොඩක් තියෙනවා. Okay, shall we? Yes, ගොඩක් තියෙනවා. Closed loop තියෙනවා පුරාම. Okay. මෙතන බලන්න. sorry, මේක. A E D C A. A E D C A. That is a closed loop. Okay. Then B E D C B. That also closed loop. Then A E C A. A E C A. That also closed loop. Then B E C B. That also closed loop. That also closed. Therefore, there are several closed loops. Then I can consider this one first. A E D C A. Ornament करना बकायदा closed loop पे बोलते A E D C A. That is the first closed loop. This is the first closed loop. Therefore, you can remove all the vectors in those directions. Mema again. What now? And now the second closed loop is this one. This is the second closed loop. The second closed loop is B E C B. B E C B. B E C B. Make a second closed loop again. B E C B. Therefore, all the vectors in those closed loops will be separately zero. And yes, there are a lot of closed loops. Mega thing. So once you remove all of them, the remaining is only single vector. The remaining is only single vector. That is AB. Therefore, R is equal A to B. If you got that one, please raise that. If you got that one, please raise that. Then another step. Close loops ටික අඳුර ගන්නවා කියලා කියන්නේ පුතේ වැඩේ almost done. හරිද? එහෙම අරන් අයින් කරනවා ගියාට පස්සේ වැඩේ ඉවරයි. සමහරවල්ලාට මේ වගේ එකම ඩිරෙක්ෂන් එකකට මේ දෙකක් කියන අවස්ථා තියෙනවා. process දෙකක් හරි තුනක් හරි එහෙම වෙන අවස්ථාවක් තියෙනවා. ඒ වගේ තැන්වලදී අපි ඒව ඇඩ් කරලා ගන්න වෙන්නේ. Okay පුතේ. හරිද? Did you get my point? මේක තේරුණා? If the lesson is okay, please raise the hand. තේරුණා තුස්සන lesson එක?